So let's go ahead and share, and I will share my first desktop over here. And let's go ahead and set these things on. Use the chat here so I can see that. All right. So for the lecture portion of class here, remember your computer's like a Miss Genie, and it's going to give you exactly what you asked for, but not exactly what you want sometimes. So computers are very much that way, especially when we're programming them. Today's lecture is going to go over, we're going to review some of this idea of classes and objects, just so we can go through one more time some of these, remembering back to this color and the point objects and classes here. We've got the constructors here that we identified previously. The constructor for the color here had two constructors. The first constructor was using the red, green, and blue elements, and the second was built from another color. This allows the color class here to be immutable, which means once you set a color, you cannot change it. We are not doing a set of another thing. All you can do is darken a color and create a new color from that previous color. So you can do that with darken, lighten, but you cannot edit a color in this case, which makes it immutable, which means you cannot change the attributes of an existing object. So you can create a new object based on that. Same thing with the string class. So before, when we were doing things with strings, you were always creating a copy of that string. It was never editing the string itself. So when you were editing a string, it was always, or taking a substring, it's always creating a new string to create that substring. So make sure you understand that concept. It's a fairly common one and will be pretty well emphasized in 159 as well. Then you've got your point class here, which is a mutable or changeable class, because you've got a getter here in the get x, and then you've got a setter here in the set x and y here. So these are items that allow you to change or reset the points inside the x and the y values, the attributes inside the point. So this is an immutable class in color and a mutable class in point. All right. So decided I'd go through the idea of arrays of objects. So I decided I'd give a new example of one here. This is going to be an array of points. So if we take this test code, let's do this out here in JGrasp. I think it's already started in my JGrasp, but we'll see. If I close all these things. All right. So I've got this point class that I've created, and it's called test points here. And remember, if you're going to use this point class, you have to import it. It's the import java.auth.point. So you're importing that point class in so you can use it inside of here. And over here, I'm taking from this code here. This is the point class here and a main in here. I've added that in here for the main. And then I've added in this code here to test if a point is in an array of points. So if we have a sample point, we're going to pass in, we can determine if it is in the array of points that we've created. So we've got an array of points out here, and then we've got this sample point that we are setting. So in this particular example, we have a point A that we're setting as and creating as a new point. It's at the origin 0, 0. So then we're creating an array of points, and this is the syntax for doing this. You definitely want to understand how to do this. This could be very useful on the final exam, hint, hint. for you as far as understanding how to create an array of an object, and then also to search through that array of objects. So this might be an activity that you may need to come back to for the final exam. Make sure you understand how to do this, and how to write the syntax and how to construct this search piece here. So we've got this item here, this points array. We're adding this point A into it, so we know and expect that when we do the found method for this array, we should find point A in it because we're adding point A explicitly by adding A. We're also creating other points, and this is another way we can do this. We can add new point objects by doing the new, and then we're using this point constructor with X and a Y value. So we're going 0.1, 2 in here, and we're adding in this item as a new point at 1, 2. So we've got one at 0, 0, one at 1, 2, and one at 3, 5. So that's the points array here. Then we're adding points 2 as a new array, and it's going to have 3 points at 3, 5, 1, 1, and 2, 2. So these are going to be the 3 other points here that have 3 other locations here. Let's go ahead and add a third point into here array. We're going to do this one in a little bit different way. We're going to say points 3, and we're going to say a new point 3, 5. This time we're going to go 0, 0. We're not going to put it as A, but we're going to add a point at 0, 0. So it's going to probably be a more interesting look here to see what this found test for array 3. We're going to go to points 3, and we're going to compare with A. So over here, this method here found, it's a Boolean return, so we're returning true or false based on the fact that we've got this test point inside the array of points. So I'm passing in a parameter of an array of points, PTS, and then we're passing also a second parameter argument in here. It's going to be a point called test. So we're going to see if this test point or the location of this point is equal to the location or is found within the points here. So we're going to set a interim variable called located equal to false to tell us if we've actually located the point. And then we're going to loop through this array of points. I'm going to do this in one of the more efficient manners for a search routine. If you're doing a search routine, a for each is a great way to do that. And you definitely want to understand how to do and construct a for each loop to get through these. This is going to be much more efficient in many ways because you won't have to worry about the indexing. You can just work with the point object instead of having to work with an array of objects, PTS sub 0, PTS sub 1, that type of nomenclature. So this is just going to be a lot easier to work with the P object or point in points. So for each point P in points, we're going to go do this. We're going to say if P dot equals test, then we're going to return true. And this will just break us out. So if we find at any point the matching point in this array of points, we're going to return true. This is the short circuit idea. The idea that was in some of the homework for chapter 10, where you would break out of the array early. Some of you had some troubles with this where you actually did not break out of the array early and you just set a variable to true. You set located to true and you kept going. This would keep you going, or in some cases would put you into an infinite loop that you would never get out of. So you'll want to avoid those pitfalls and those traps. Make sure that if you're trying to find something, that once you found it, you can go ahead and short circuit the rest of the for loop here and just return true and get out of this method. This is definitely a technique you want to be well aware of and understand why you want to do this, because otherwise you may not come up with the right answer. Or if you're trying to see the first match of it, you may come up with the last match of it. If you're trying to do that, that would be an incorrect answer as well. So make sure you understand how this works and why you would want to set this up this way. Otherwise, we're going to keep going through the loop to the next point and check the next point until we get to the end of the points array. And if we have not found one, we'll return located, which is this value of false. We could also just in here just say return false because it's a pretty trivial case. We don't even need this located method in here. But I usually like to set up a interim variable in case we need to do something with it inside of the array. Not a bad practice to do that and get in the habit of doing that. So, but again, you could just return false in here, and that would, in this case, you could take out a line of code and then just return false. It would be a little bit more streamlined and simpler, more elegant. All right. So when we run this for found against points and A, we're going to go in here, and it's immediately going to find this, and then it's going to kick out and say true. For points 2, we're going to come in here, and it's going to look, and it's going to see if 3.5 is equal to 0.0. It's not. 1.1 is not. 2.2 is not either, so it's going to come out, and it's going to come out with a false. Then with the third one here, we're going to have point sub 3 and this A. In here, it's going to go to 3.5, and then it's going to go to 0.0, and these are equal because they're the same value of x and y. That's what equal means within the points class. So that dot equals method is checking if x and y are equal for the 2 points. So this will break out of here and return true when it gets to that. So let's go ahead and run this or compile it. Then we'll go ahead and run it, and we should get true, false, and true as we're expecting. So make sure you understand why this is coming out this way, even though we're not putting A in explicitly into this third array. Its value is the same as the other point, and so it's going to come out with a true on this third one. So wanted to try and walk through an example of this. Also, the nomenclature and how to create these test arrays. This may come in handy for arrays of objects within the test that we are having to do for the final programming assignment as well. So you may need to create some test array objects, and this is how you're going to create objects and new objects and an array of new objects, especially maybe word slices and that type of thing. So make sure you understand how that works as well. All right. So that's pretty well the portion of the lecture I wanted to go over. I'm going to go ahead and turn off this portion of the recording and then record to another recording the rest of the stuff for the PA.